the class, if you moved on to the last WebAssign problem set from the energy chapter, this one's all about springs and some potential energy graphs. And so here will be some hints probably for the first 2 or 3 or 4 problems. Starting with number 1. Number 1's a real straightforward one. They're asking about the energy stored in a spring, or in this case it's probably like some sort of elastic rubber band, but the same deal. And that's just kx squared over 2. That k is the spring constant, which I think is given in the problem. The x is also given in the problem, although we don't even need to make any unit conversions, so we're just doing that. And nothing too tricky about that one. Nice, easy one to get you started. Number 2 is a little bit trickier. They've got a few different pictures there, kind of like different situations where they're showing where the block can be at a sort of like a equilibrium position, kind of like a rest, or it can be stretched one way or compressed the other way. And so we've got a variety of questions for that one, I guess about 4 of them. And for all of them, they're referring to how much work do you have to do. Well, in general, work is the change in energy. And in these cases, it's kind of like saying the change in energy in our spring, which is kind of like saying the energy in our spring, what it ends up at, minus what it starts off at. So kind of like a change in the 2 energy amounts. How much does it differ by? The amount that it differs by is what you had to do. All of these are listed, actually before we even get to that, you definitely need to use, in the beginning of the problem, you want to find the k. That k is the spring constant. That is, don't know if it's different for, it is going to be different for everybody. So gravity works. That's F over the change in x. So once you get that k, you can get that for your problem and continue to use that. The x's, I think, are given in centimeters, so you'll want to convert them, assuming that this one's in meters also. I guess you probably could do it in like newtons per centimeter, but then you'd have everything uniform. I would say just change everything to meters. It'll make it, I think, easier in the long run. Some of these answers might be negative. That kind of makes sense. That would be like saying that this number is bigger than that one. And so a negative energy means that you're not doing something, that the spring is doing something. You can kind of relate that to the dot product thing that we learned about, and that's, we don't care about that too much. So let's go on to number 3. Take a look at that one more time if you need anything. Number 3 has a couple little wrinkles in it. It's kind of similar to number 2. They're saying that you're pushing with a certain amount of force and you are holding it stationary at a certain position. And then we're going to do some more work to kind of compress it, or it doesn't really say, I don't think, but we're definitely going to move it. So once again, we are going to find the spring constant. If you don't like this format, this is the exact same thing as that, which we probably learned about in class. This is called Hooke's Law. This is just Hooke's Law rearranged to get the k. So once you get your spring constant, we can say, well, once again, we know that work is the final state of the energy of the spring minus the initial energy of the spring. They give us a number here. I'm just going to put a check mark there. We can put in stuff for both of these, except we've got all these. We don't have this one final position, this x right here. I think that's the right one. It might not be. Yeah, new position, so like a final position. So we've got numbers for all these, but we don't know x squared. So we do have a quadratic equation. If you would like, you can graph that on your calculator. You can graph it on Desmos. If you really like torture, I guess you could use the quadratic equation for this, but I wouldn't want to do that just because it's a pain in the butt. But you definitely do want to solve for that x. When you do get that x, if you made unit conversions, I think for this particular problem it's in centimeters, so you might have to do, just put a question mark there, you might have to change back to centimeters. And in this problem, the wording is kind of weird. They want two different positions. That's because this x squared, whenever you solve for any x squared, there's two answers. Kind of like if you were to do the square root of 4, you get +2 and -2. And so for this particular webassign one, when they say the smaller value, they want you to put in, say, -2. When they say the larger value, they want you to put in +2. That's what they mean by those two values. That's not really very clear. So I definitely wanted to help people out with that so you're not frustrated over something kind of silly like that. Okay, so that's 1, 2, 3, and I think I'll actually stop there, and we'll do a separate video for the remaining ones.